we want to find if, okay, so we have to find stress A and stress B. Okay, and you have to construct 3D Mohr circle, right? Why? So I'll write you. So you have to construct 3D Mohr circle to find, stress max and stress mean, right? So to find stress max and stress mean, okay? So you want to know that this is equal to stress A and the minimum is at stress B. Okay, this is very important. If you don't construct, okay, what if, like in the quiz, okay, in the quiz we have, I deliberately put another compression load down here. You have to check, okay, because that will determine the stress max and stress mean, what the values are, okay. So I will kindly advise you to look at the marking scheme for quiz number 9. Okay, so quiz number 9, some of you use the wrong value. Okay, is there a quiz this week? There is a quiz this week. Okay, right. So we're going to construct 3D Mohr circle. Okay, so we're going to have so we're going to have minus 20 I don't know how I have enough space, minus 8 6 4 2 0. I have not enough space, sorry. I will draw it below, my apologies. Okay, so we'll have two, 4, 6, 8, 10. This is a big circle. Yeah. So this is minus 20, 18, 10, 8, 6, 4, 2, 0, 2, 4, 6. Normal stress. 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 2, 4, 6. Okay, so there is normal stress. Then you have shearing stress. Or shear stress. Element rotate clockwise. Right. So we have 2, 4, 6, 8, 10, 12, minus 2, minus 4, minus 6, 8. Right. So we know that stress Z is on this line. Right. And in fact, we can draw our point Z. Okay. So we know that point Z is over here. Okay. So what do I mean by Z? Right. So this is my X, Y, and this is the Z. Okay. So we know that the shear we are running at 9. Okay, so the shear is at 9,000. So this is one of our shear line, and the shear is nothing to do with whether positive shear or negative shear. It depends on the rotation on the element, right? So one of the stress is at 15. So at 15 minus 15, in fact, compression. And the other one is at 2. Right. So point X. So this is your stress X. Right. So this is your stress X line. This is your stress Y line. So the element rotation, if you look at here, point X will be anti-clockwise at 9,000. So this is your point X. And this will be your point Y. Okay. So now you can draw a straight line. Okay. Then immediately you can calculate your stress average. Okay. So you can calculate center of the circle. So this circle is your XY plane now. Right. So center of circle. So stress average for XY plane is equal to 2,000 plus by minus by 15,000 divided by 2. All right. So 2,000. So it's 13,000 divided by 2 is 6,000 minus 6,500 psi. Okay, which we have down here. So I'm going to sketch in green the center of the circle. Okay, so it's a bit off, but it's okay. Okay, then we calculate our tau max or radius of the circle. So this will be equal to square root or minus 6,500. Oh, no, not minus 6,500, what I'm talking about. So this will be 8,500. Okay. So 8,500 squared plus by the shearing stress, which is, or the shear stress is 9,000. Okay. So 8,500 squared plus by 9,000 squared. Okay. Square root is 12,379. So 12,379 psi. Okay. So I'm going to sketch, right? So 12,379. Okay, so calculate the principal stresses, stress A and B. So it's minus 6,500 plus or minus 12379. Okay. So this is go to minus 6,500 plus a 12,379, 5,879 and psi. And the other one is 6,500 plus 1 18879. Okay, so 5, 8. I'm just eyeballing this. Okay, so 5, 5, 8 should be somewhere around here. And then the other one is minus 18,879. Okay, as I say, I'm just eyeballing this. Okay, so this is our Mohr circle, and we realize that the XY plane, right? So this is our stress B, and this is our stress A, right? Is the biggest circle. Okay, so we can construct the other two circles, right? So we can construct the other two smaller circle. Now in your in your exam, you have to, when you see questions like this, you have to construct 3D Mohr circle. If you don't construct 3D Mohr circle and check, there's a possibility marks will be deducted or your answer will be wrong. Okay, so this will be, so the first one, this will be for your XY plane, the one that we have just drawn. This will be for your XZ plane. And the last one, the last circle, okay, again, I'm just going to eyeball this. Okay, the last circle that we just drawn over here. This is for your YZ plane. Okay, right. So this so the XY plane happened to be the bigger circle, right? As you can see. Now, why you have to draw this is because if stress Z is not equal to 0, like your quiz, right? Then let's say it's tensile. Then over here will be your what? Stress Z. Then the value for stress A and stress B are wrong already. Yes or no? Okay. So you have to construct 3D Mohr circle to check. As I said, marks will be awarded. Okay, for checking. Okay, marks will be awarded for checking. Okay. So now this is minus. Okay. So from here, right, we are going to apply stress A over stress ultimate tensile minus by stress B over stress ultimate compression. Okay, so this will be, so stress A will be equal to 5879 divided by the ultimate tensile, which is 10 times 10 to the power 3, right? And then minus, this will be equal to minus 18. Stress B will be 18 minus 818,879, right? Then divide by ultimate compression, which is equal to 30 times 10 to the power 3. Okay. So this is equal to 5879 right, 10 to the power 3 is equal to 0.5879, and then plus 18879 divided by 30 to the power 3 is 0.6293. So this will be equal to 0.5879 plus 6293 is equal to 1.2173 or 72. So when that's the case, therefore the structure will yield with Mohr's criteria.